Good day, students. Welcome to mathgotserve.com. In this clip, we're going to be going over how to find powers of complex numbers in polar form. Alright, the instructions for the example that we're going to do are as follows. We are to simplify, then express the result in two forms. You're going to express the result in polar and rectangular forms. Okay? Alright. So the example that we're working on is as follows. If the complex number z in polar form is given by 4 cosine pi over 2 plus I sine pi over 2. The task is to find z raised to the third power. Okay? Now, the first thing we're going to do to guide our problem solving process is write down the formula for the process. Okay? So let's say you have a complex number z raised to the nth power. So let's write it down in polar form. You have r cosine theta plus I sine theta. So this complex number, we're raising it to the nth power. Okay? So, what does the formula tell us to do? If you have a scenario like this, all you do is you raise the radius to the nth power and multiply the angle theta by n. Okay, so you're going to have r raised to the nth power. Okay, cosine n theta, so multiply the power by the angle theta, plus I sine n theta. Okay, so that's basically how you raise complex numbers in polar form to a specified power. Okay, let's go ahead and apply this example to this particular scenario that we are dealing with. Let's apply the formula to this example. So we have z to the third power. That's what we are asked to find. So what is z? Z is 4 cosine pi over 2 plus I sine pi over 2. What we're doing is we're raising this complex number in polar form to the third power. Okay, so let's go ahead and apply this formula here. But before we do that, can you see what r, theta, and n is in this setup that we have here? It's just a side point. Let's go ahead and write it down. R is 4. Theta is pi over 2. And n, what you're raising the complex number in polar form to, is 3. Okay? So let's input it into the formula. So r is 4 raised to the third power. And then we have cosine of n, which is 3, multiplied by the angle pi over 2, plus I sine n again, which is 3, multiplied by the angle pi over 2. Okay? Now let's simplify. What is 4 to the third power? 4 times 4 times 4 is 64. Now, when you're multiplying the fractions, you can just write 3 as 3 over 1. Multiply the numerators and the denominators, and you have cosine 3 pi over 2 plus I sine 3 pi over 2. And that, ladies and gentlemen, is the answer z to the third power expressed in polar form. Okay, so this is the polar form, the form that clearly explicitly states what r and theta are. Okay? Okay, now let us go ahead and answer the second part of the question. Remember, we were to express the answer in rectangular form also. Okay, so in order to do that, we'll simply determine what the x and y components are by evaluating cosine 3 pi over 2 and sine 3 pi over 2. To assist us with that task, we're going to make use of our unit circle. So let's go ahead and sketch that. Alright, so there goes our unit circle. Now the goal is to locate where 3 pi over 2 is on the unit circle. Now you can convert 3 pi over 2 to degrees in order to determine its location with ease, but you can also do it with radians. Alright, so the whole circle is 2 pi, so quarter of a circle is 2 pi over 4, which is pi over 2. Okay, so starting from 0, if you go a quarter of a circle, you're going to go, that's going to take you to this angle right here, which is pi over 2. This is pi over 2. We're looking for 3 pi over 2. Okay, so that's pi over 2. Go another quarter of a circle. Then you're going to add pi over 2 to pi over 2, which is pi or 2 pi over 2. Not good enough. We have to rotate another quarter of a circle. Remember, the target angle is 3 pi over 2. So third time, pi over 2. Notice we're rotating counterclockwise, so that means we're adding the angles. That takes us to this point right here. And that's the desired point. This point is 3 pi over 2. Okay? Now, what are the coordinates of that point? On our unit circle, remember that the radius of the unit circle is 1. That's why it's called the unit circle. So we're just going 1 in the y direction. We're not going left or right, so x will be 0. The x coordinate will be 0. And the y coordinate -1. Alright, so for the unit circle, you have to remember that the x coordinate is cosine and the y coordinate is sine. Okay, so you can use the idea y sin to help you remember that the y coordinate is sine, and then the other coordinate x is cosine theta. Alright, so we're going to use that to determine what cosine 3 pi over 2 and sine 3 pi over 2 are. So z to the third power is going to be 64 times cosine 3 pi over 2 is the x coordinate of this point on the unit circle, which is 0, plus I, sine is the y coordinate, which is -1, like that. Okay, now let's go ahead and simplify. We have 64 times 0 minus I, and then we just distribute 64 to these two numbers, the real and imaginary parts of the complex number in rectangular form. So we have 0 minus 64i, which simplifies into -64i. It is a pure imaginary number. Okay, so this is the rectangular form of z to the third power. Okay, so this is a rectangular form. Alright, so that's how you find the powers of complex numbers in polar form. Thanks so much for taking the time to watch this presentation. We really appreciate it. If you found the contents of this tutorial helpful in your studies of complex numbers, to give us a thumbs up. Your positive feedback is very valuable to us. If you have any questions or comments about the contents of this presentation or any pre-calc concepts in general, just place it in the comment section below, and we'll be more than glad to support you. Don't forget to subscribe to our channel for updates to other tutorials such as this. More clips Support tools and tutorials can be found on mathgotserved.com. Go ahead and check it out. Thanks again for watching and have a wonderful day. Goodbye.